Okay, I think we have time for questions still. If anyone has a question, if you can raise your hand, they'll bring the microphone over to you.
Thank you for the wonderful presentation. Everything is very valuable and appreciated. So I have a question for Mr. Khoo. I don't know if I pronounced your last name right. For the project they show in Singapore, I see a lot of bridges connecting the a bunch of residential towers. So the question is, how you resolve the either wind load or any kind of lateral load, the forcing between the buildings?
If you look at the 7 towers, there are 2 sets of bridges that are longer and 4 others that are smaller. So what the engineers have done is actually to take 2 towers and the long bridge as one sort of contiguous structure, so there's no movement joint in the big bridges. And these 2 buildings then move about 300 mm in amplitude, and the smaller bridges actually have a movement joint in them. So I think that way, by linking up 4 of the towers, the movement becomes smaller. So
thank you.
Yeah.
Respective signature tower, seismic design, but lots of this thing is there. The Indian plate, the Australian plate. Is it designed only for the horizontal movement or for the earthquake vertical movement also?
Well, we will do the analysis for the performance especially. We consider instead of horizontal also vertical. So we have a series for the digital record to do that.
So I have a question for, could be either for Stefan or could be for you. Coming from Chicago, we have a somewhat different neighborhoods, and each neighborhood has different cultural emphasis to each one. And so talking about the idea of taking the layers of Hong Kong or creating sky bridges between buildings, certainly something the council is keen on. It may work in a utopia, but how does that concept work in a city like Chicago, where you take the different cultures of the city and then you start to separate them vertically? How do we avoid taking the socioeconomic divisions that happen along the ground plane and then rotating them and bringing them vertical? And if you don't have an answer for 100 years of problems of socioeconomic...
I believe that the connectivity on various levels is desirable, right? It gives you flexibility. It creates connectivity between the components, but it shouldn't be exclusive. In other words, you have quite an active street network now in Chicago, and I think one should build on that, and that should be retained in any case. And connectivity between the buildings can really only be achieved when the buildings have certain proximity with each other, right? Unless you create very long, elevated pedestrian networks.
But let's say that we did connect buildings together. How do you keep it from being one economic level at this elevation, another economic level at another elevation? Because you can divide it very easily in the streets of Chicago between one economic level here, and maybe a highway divides them, and another one here. Once you rotate it and we have a bridge, a building, a bridge, a building, it seems like it has the potential to have that same sort of division. And what steps can we take as we pursue this idea? What steps can we take to avoid some of the problems of the ground plane?
I think in the Pinnacle at Duxton, the model for vertical connection, I think we had originally imagined that you could take even more programs up to the higher levels. For example, I don't know, halls and communal halls and function rooms and such, cafes and all that. I think the problem at this point in time of Singapore's city development is that someone has to look after this property, And being a property that's high up above the city also has its challenges, wind and heavy rains or monsoon. And what about, someone decides to throw something down, and if a tree branch falls, there's all this kind of very pragmatic issues that are also being considered. So I think right now in Singapore we have actually decided that the 26th floor will become a private communal area. Only the residents can access this floor, and they can bring their friends and families there, of course. And on the top floor, there is a huge, a long list of rules that are sort of boundaries that are being set. And I suppose over time, when we study the way these spaces are being used, the boundaries can be adjusted. But right now, it's actually quite tight. You're not supposed to have your pets up there, and all sorts of restrictions. But there's a huge concern about this being a public space, because I think in a lot of high-rise observatories, they are all controlled environments. People pay to get up there, and there are wardens patrolling the space all the time. But in this case, anyone can go up there. If you visit Singapore, you pay $5, you can get up there and just walk around. So it's actually a very, very open space. So I think in a city like Chicago, for example, I think if we sat down today to design a city, and looking at how our models would, come so close together, we would be very afraid to actually propose something like Chicago. But when we were there walking on the streets, it's actually a very well connected and very compact city scape. And I think at some point when cities like Tokyo and Singapore or Hong Kong develop to a level of density where the street becomes extremely congested, the first actually natural tendency is for these cities to go underground. So because of the mass rapid transit connections, so as and when the underground becomes over congested, I think the new level of connection becomes higher and higher up. And I think Norman Foster has designed this huge highway that's supported on 150-meter tall pylons. I imagine that, when our city becomes extremely close and extremely compact, that buildings could actually support infrastructure right on the roof. And at the moment, we have air rights, we have all sorts of legal restrictions and boundaries. But once this is opened up, I think one will find that the connection actually increase the sort of socio-economic activities. In Orchard Road, Singapore, the undergrounds actually enhance the value of the properties that are being connected. I think building on a bridge has actually posed quite a big challenge in Singapore. A lot of the private developers have not actually gotten into the act of negotiation and all that. But I think for new developments to propose bridges is much easier. So I think for a city like Chicago, a lot of the buildings are extremely mature. To suggest connections now might be a lot more difficult than if they were brand new, I think.
Great. Any other questions from the audience? Oh my.
We often make a case for tall buildings with density issue. So we say it is a solution for density. But it's not necessarily. It's not the only solution for density. Traditional cities did achieve high density with low rise, and European cities achieved high density with mid rise. And it's only for super density where we can really pack many people in a small area. However, when we get to super density with super tall or very tall, we end up spacing these buildings apart because we cannot really pack them so close. So we need to provide open spaces, green spaces, so we end up almost with the same density, ironically. So it's not really like, at the end of the day, you see like, well, what did I achieve? I just moved people from the ground plane to the upper plane, and I created semi-fake public spaces in the sky. So I deprived them from the actual life on the street, right? And then I say, well, no, I need to re-study how the tall building needs to meet the ground plane, and I need to animate the ground plane. And we've seen in the case of ICC complex, where the ground plane is now moved to upper or lower, and then again, the street life in that area is really very poor. So what are we trying to achieve?
I was trying to convey that in some of these models I've shown. I think Hong Kong has taken it to the extreme, the segregation of pedestrians and vehicles. And that resulted in this layered idea which sterilizes the ground level, which is a wrong way to go, I feel. But that development I've shown in Shenzhen, that has a very active streetscape, and it integrates a super high-rise building. And I think the challenge with super high-rise buildings is that they're very often perceived by developers to be standalone type projects, just like Qingmao or the finance center here in Hong Kong. They are standalone buildings, and to be able to move around within the streets, you have to cross roads, you have to walk certain distances to actually get from one building to the next. What's missing is that component which brings these high-rise towers together. And I feel that in Shenzhen, that has been done quite successfully, because it has a joint public realm which activates the streetscapes. It also has internal good connectivity through the retail. The retail sits at grade, which is very different to the ICC, where the retail is lifted off the ground level. So you have the connectivity on the elevated level as well as at grade. And I feel that is the model we should be looking at. And I fully agree with you, just building high-rise for high-rise sake and creating big spaces between the high-rises is not the way to go. Yeah, thank you.
I think if you look at a connected city model, it's already happening whether we want to or not, and it's just at various different levels that are much lower. I think can easily imagine some of these programs actually shifting all the way up as and when the density and towers actually allows it to. And I think in a city there are also different grades of public and private spaces that you can then grade along the sort of the vertical strata, and I think at the different connectivity levels as well. Things certainly when we think about how the cities can become a three-dimensional grid, then I think we start to become even more connected and less reliant on cars as a form of transportation. And I think our modern airports are actually a very good example of horizontal connectivity that can see itself being exported up into the air, where you use other forms of mechanized people mover system like travelators, for example.
Question for the, Anil here of Bureau Airport, Mumbai. Question for the last speaker, my apologies, I didn't get your name. Your tower in Jakarta, clearly it's totally dominated by seismic. Just questioning how you handle the soil structural interaction to work out your structural response, dynamic response.
Thank you. So for this tall building, we would like also to do the structural soil interaction, but the existing building, some consultants still not doing. So we just assume all is fixity in the ground and also sometime in the lower basement. But for this tallest building, we will do it.
Short question. First question is signature tower. What about the basic wind speed in Indonesia? And second one is why don't consider the damping system to reduce the seismic load? You said seismic load is 2 times than wind load. So do you consider damper system for schematic design?
Sorry, can you say again for the question 1?
Yeah, basic wind speed in
basic
Indonesia.
wind speed. Yeah. So from RWDI laboratory test, he mentioned 40 meters per second. Usually we calculate sometime is 32 meters per second. So for this building, we assume is for 100 years return period is 40 meters per second. For the damping, yes, at that time we already study whether we need to use it or not. But for this building, I think we don't need damping, is already strong enough. So we don't use like 101 or things that doesn't necessary. Let's say like RWDI report regarding the predicted acceleration is still lower than the limit.
Okay, I think those are some pretty thought-provoking presentations. So we're going to conclude. We'll give each speaker a gift. If you give one final round of applause and thank them for their time.